Hey everyone, welcome back to Bugnojutsu. Today, we're diving into a really interesting game theory problem from LeetCode 3227. Vowels Game in a String. This one involves two players, Alice and Bob, taking turns to remove substrings based on vowel counts. At first glance, it feels tricky, but once you recognize the underlying pattern, the solution becomes surprisingly simple. Let's walk through the problem, break down an example, and I'll share my method for solving it step by step. By the end, you'll understand exactly why the logic works and how to analyze similar game problems in the future. We are given a string S, and two players, Alice and Bob, play a game with the following rules. Alice always starts first. On Alice's turn, she must choose and remove a non-empty substring of S that contains an odd number of vowels. On Bob's turn, he must remove a non-empty substring that contains an even number of vowels. After a substring is removed, the remaining parts of the string are concatenated, and the game continues on the resulting string. The first player who cannot make a valid move on their turn loses. The vowels we care about are the standard English vowels, A, E, I, O, and U. The challenge is to return true if Alice can guarantee a win assuming both players play optimally, and false otherwise. Let's look at the provided example, S equals LeetCoder. Step 1, Alice goes first. She looks for any substring with an odd number of vowels. In LeetCoder, she can choose LeetCode, which contains 3 vowels, E, E, O. After removing it, the string becomes dir. Step 2, now it's Bob's turn. He must pick a substring with an even number of vowels. In dir, the substring D has 0 vowels, and 0 is even, so Bob removes D. The string becomes Step 3, Alice plays again. In she can take the whole string because it contains 1 vowel, E, which is odd. The string becomes empty. Step 4, Bob has no valid move since the string is empty. Alice wins. This example illustrates that Alice only needs the presence of at least 1 vowel to guarantee a winning strategy. Here's the insight that makes this problem simple. As long as there is at least 1 vowel anywhere in the string, Alice can always force a win. Why? On her first move, she can pick just that single vowel as her substring. Removing it leaves Bob with a string that has 1 fewer vowel, changing the parity of the total vowel count. Because Bob can only remove substrings with an even number of vowels, Alice can keep forcing situations where Bob either has no valid moves when the vowel count becomes 0, or is forced into a position where Alice can always respond with an odd vowel substring. If the string has no vowels at all, Alice can't make any move on her first turn, so she immediately loses. That's why the implementation just checks for the presence of a vowel. If it exists, return true, Alice wins, otherwise, return false. Time complexity, N, where N is the length of the string. We only need to scan the string once to check for vowels. Space complexity, 1, since we only use a small constant set of vowels and no extra data structures proportional to N. This problem looks like a game theory puzzle requiring complicated dynamic programming or simulation. But the key is pattern recognition. Optimal moves on both sides collapse to a simple rule about the existence of a vowel. Problems like this often appear harder than they really are, so always look for ways to simplify the rules before jumping into heavy computations. This is also a great example of how understanding parity, odd versus even, can turn an intimidating problem into an easy win. And that's it for today's problem. Alice can always secure the game if there's even a single vowel in the string. How cool is that? If you found this breakdown helpful, don't forget to hit the like button, subscribe to Bugnojutsu, and ring the bell so you don't miss more deep dives into tricky LeetCode problems. Share your thoughts or alternative approaches in the comments below. I'd love to hear them. Until next time, keep practicing, keep recognizing patterns, and stay sharp. See you in the next video.